previous one. Maybe because the topic of data is much more interesting, but we are going to have, in any case, we are going to have some sort of recap of the previous lessons. So I'm Elena Giglia. I work at the University of Turin, where I'm head of the Open Science unit. And some housekeeping before starting. So Gabriela has already put the link to the slide on Zenodo. Actually, it's not only the slide of today, but you will find the same. It's the same, let's say, box in which I put also the slides of the two previous lessons. And our meeting today will be recorded. So if you don't want your name to appear, please, or your face to appear in the video, please keep your video, your camera switched off. So I start sharing my slides, if it works. Gabriela, can you tell me, please, if you can see the slides?
Yes, now we can see it very well.
Okay, perfect. So as we were saying, the slides are available in Zenodo, and they have a Creative Commons license, so feel free to reuse them, provided that you cite me as the author. And the same is true for the background slides. So you can feel free to reuse them. They are available on Flickr with the same license, Creative Commons by. What are we going to see? So we, as we just said, we are at the third meeting. During the first one, we saw why do we need open science and what is open science. On our second lesson, we saw some practical tools to open up every step of your research cycle, plus a focus on open access, which seems still to be an issue among researchers after 20 years from the Berlin Declaration in 2003. But anyway, so today is the third lesson. We are going to see something about data management and why we should care about our data. Next time, we will see some practical tools to verify your data. And we will see also the three most, I would say, used, the widely used tools to draft your data management plan. And during our last lesson on March 27, we will see open science provisions in Horizon Europe. So if you were not able to attend the first two lessons, please feel free to ask Claudio for the recording. Maybe we can put the recording also on the same Zenodo record so that you can have a sort of, recap. But anyway, why you should care about open science? Because in Horizon Europe, your project proposal is evaluated also on open science. So that's the main difference between Horizon Europe and Horizon 2020. In Horizon 2020, you just had some obligation at the end if you were funded. But in Horizon Europe, in order to be funded, you need to show the Commission how you are going to adapt and adopt open science practices. So that's why you should care not only about fair data, but also about open science and the tools to open up every step of your research, which we saw in the first two lessons. Oh yes, so let's go to the Menti as like we did in the previous during the previous lessons. So please go to www.menti.com, and the code to vote today is 62164978. So let me stop sharing. I think, okay, it's done. And let's share the Menti screen, which is this one. Can you see the Menti? Gabriela, please, can you confirm that you see the Menti?
Yes,
okay.
We can now.
Okay. Okay. So as you can see here, the code to vote today is 62164978, and the website is www.menti.com. We are going to have a sort of check at the beginning, and afterwards we are going to see a video. Unfortunately, I forgot to check with Claudio if it will be visible for you, but anyway, we will try. So please connect to the Menti. We are waiting for you to connect. I saw at least 22 people this morning connected, so please join us on Menti. It will take just a few moments if you can collaborate with us, because it's important also for me to know which topics to stress today during the lesson. And it's also important for you to test your initial knowledge about, or better not knowledge, but awareness on data management. So please join us on www.menti.com and using the code 62164978, you will be able to vote. I see 7 people connected for the moment. 8. So while people is joining, please vote which is your field. Just to sort of present yourself. So humanities, social sciences. Yeah. So mainly from social sciences, great. And please, I forgot to tell you at the beginning, as the lesson is being recorded, please absolutely keep your mic switch off, because if not, you will create some noises and the recording will be spoiled for future listeners or watchers. So please keep your mic absolutely switched off. So we have 17 people, mainly from social sciences, humanities, life sciences and medicine, only 2 people, and mathematics, physics or chemistry 2, engineering or architecture 1. Okay, so please give us your definition of data. If you have to define data, what are data for you? This is very important for the lesson we are going to have this morning, because it gives us your perspective on data. Measurement or statistics. materials for research, information, structured or unstructured information on any format possible, ingredients to validate results, collection of information, facts and statistics collected together for reference or analysis, information. Okay, that's the same collection of facts, figures, or other pieces of information that can be measured, observed, or recorded. Okay, information, numbers, statistics. Okay. Data we need or create for research. Okay, that's very interesting. Yes, maybe it depends on your field. Okay, we have another one. Information, personal or not, that we live by using the internet and whatever is linked with apps. Okay, that's if you refer to data analytics. Okay, it's not what we are going to explore this morning. Maybe I should have put research data. Research data are measurements done in the frame of the research. Okay, these are all the totality of information regardless of the format used in a given subject field and regardless of type of recording, text, audio, video, whichever form the information is recorded in. Social, okay, this one I don't get, but anyway, the definition I personally like more is this one. Materials for research, because actually it's interesting that anytime we refer to data, we tend to imagine something like quantitative, okay? You said measurement, you said statistics, you said numbers, but if you think about an archaeologist, data for archaeologists are the piece of ceramic they find in a field during an excavation, right? So, or for if you think about a philologist, a researcher studying, for instance, Dante Alighieri, data for a philologist are manuscripts or maybe medieval codes or something like this. So basically, data are any material we use for research. And I also liked this, data we need or create for research, because in some cases you create your own data, okay? Because you collect some data. In other cases, if you are, for instance, in the humanities, you need data in form of books, bibliographies, or whatever. And I also liked this one because it's the wider definition, so the totality of information regardless of format used in a given subject of field. Okay, so this is a wide definition, and it's quite similar to the one that we are going to see during the lesson this morning. But it was important to see that usually when we think about data, we think about numbers, okay, which is not the case. So data are not just numbers or statistics, okay? But thank you for giving your feedback. The other one, where do you store your data? This is very important for the lesson of today, the first part of the lesson today. In SPSS. No, sorry, social science is not the right answer, right? I mean, where do you keep your data? On your laptop, on the cloud, on a USB drive? Where do you store your data? So social science is just maybe your field of interest, but it's not where you store your data. And also SPSS, if I correctly get it, is just a software for statistic analysis, right? But it's not a repository, it's not a place where you store your data. Okay, multiple places depends on the warmness. Okay. Okay, if you are using it or not. Laptop and cloud, laptop and paper. On my computer, a copy on a USB key and one on the university cloud, great. Multiple location depending on the format, either digital or physical notes, papers, preferably both. Okay, that's a good answer. That's a good not answer. It's not good or wrong. It's a good approach, I would say. It's a good habit to store your data in multiple locations. The cloud of university institutional server, okay? Okay, so basically, yeah, laptop plus email. Okay, email, it depends on the size, because if you have huge size of data, maybe the email is not the most suitable place. Okay, on my laptop, I would advise you to change your habits, because if you store your data just on your laptop, your laptop could be stolen or could be forgotten on a plane, like as it happened to a colleague of mine, can broke in any moment. So if you just store your data on your laptop, it could be risky. And also, if you store your data just on the cloud, again, it could be risky mainly if you are in the social sciences, if you are dealing with personal data or GDPR sensitive data. The cloud is not the right place to store your data, because it can be broken again. There can be a data breach. So we will see that what we are going to talk about this morning are also techniques to properly store and backup your data. Mainly on the GitLab of the university. That's great. Okay. Another question for you. Have you ever lost your data? Yes, because it happens. Usually it happens at a higher ratio than 6-4, 8-4. Because it happens. You can, okay, your laptop can be stolen or can break or something like this. So 9-5. So for people who answered yes, when and how, mainly how, why? So why did you lose your data? Well, so please tell us the reasons. Maybe for instance, the hardware failed, or the USB drive got lost, or something like this. So how did you lose your data? The storage had been damaged, hardware problem. Okay, that's very common. Yeah, indeed. Software bug. Oh, that's another reason. That's harder to prevent. Hardware failure, software failure. Hacked email account and simply lost notes and papers. Yes, it happens, okay? It happens. The target years ago for hardware failure, change of computer, hard drive not recoverable. Yeah. So as you can see, it happens. And that's why I would advise the person who replied just on my laptop yeah, to change to change the habit and to start having a proper backup and storage strategy. When there are problems in PC, okay, perfect. And another situation, so have you ever experienced to open a data file and not being able to read or interpret the data? Yes, 9, 10, 11, 12. Okay, and if yes, why? Corrupted file, the date format, yes, that's mainly the issue. Corrupted file. This is very common. No explanation on the meaning of the variables and the construction of the dataset. That's the main problem. That's the main point we are going to address when we will dealing with fair data, findable, accessible, interoperable, and reusable. So thank you for this feedback. No instruction memorized, yes. The date format, okay? So the data format maybe, or date like years, and addresses has changed, okay? So maybe this is the reason why you couldn't find the data but not interpret the data. Corrupt file, completely incompatible file format, and the necessary software was way beyond my capabilities at the time. That's another important, very important point. So thank you for this feedback. The software, sometimes you have to use a specific software to address or to read, simply to read a file, and it was beyond your capabilities at the time. Okay, so thank you for this feedback. Okay, let's see the next one. Ever happened you yourself not to be able to remember what was in the content? What was the content of a column of a spreadsheet? Yes, yes, yes. So as you can see, this is very common because as we are going to see during this module, the first reuser of our own data are ourselves. Okay, so we are the first reusers of our own data. And you are confirming it, 13 yes and 2 no. And again, why? Because maybe you forgot to label the column, or you simply added no legend to the spreadsheet, forgot to label. Okay, that's very common. Forgot the label, okay, and this is common because maybe you collect the data at the beginning of your research, and then when you are writing the paper, or if you are a PhD, when you're writing your dissertation thesis, then you completely forgot what was the content of the. Let's see this one. Forgot, did not think to add information regarding my thought process at the time, then too much time passed to remember accurately. That's precisely what we are going to see in the FAIR data. In the R section of the acronym, reusable, this is about documentation. So if you have experienced that if you don't properly document every step of your research at the moment that you are doing your research, then in the future it will be difficult to get back to your, as you said here, to your way of thinking at the time. Okay. So it's a great lesson. Thank you for pointing out. You need to document your research while you are doing it. Okay, that's a great feedback. Thank you. The other one, yeah, some sentences. You have to vote here. 0, you don't, you strongly disagree. 5, you strongly agree. Research data are mine. I can't share my data as they can be misunderstood. I can't share my data as you would need a software to interpret them. Data management plans are just a burden. I can put all my data on the cloud to safely store them. Please tell us if you agree or you do not agree with these sentences. And as you can see, there will be a ranking. Sorry again, but today I got a cold. Yesterday we had a beautiful sun, so maybe I was too optimistic, and then today that's the way I am. Okay, so research data are mine, 3.1, 2.9. Okay, so thank you again for your feedback. Actually, the first sentence, I know it will be shocking, but it's not true. Okay, it's not true because we are going to deal a lot with the rights, the copyright on data, because actually there is none, and we are going to go in depth. I can't share my data as they can be misunderstood, or you need a software. This is precisely why we need fair principles to be applied to your data, because as we were saying, you need to document everything, and you need to give access also to the software. You need to interpret the data. And as we already discussed, seeing one of your feedback to the first question, I can put all my data on the cloud to safely store them. It's not true if you are dealing with sensitive data, because the cloud is not the right place to store them, okay? I think that's it for us today. No? Okay. So ever heard about the FAIR principles before this course? Okay, 9 to 9. And for people who replied, yes, I'm curious where. Was it a conference? Was it another training course? A colleague? AU projects, of course, because they require your data to be fair. Anywhere else? Another training course? The data management plan? Okay. And let's see. Oh, sorry, this is wrong. So this is the first question. Ever heard about the IOSC before this course? Okay, the results are, in this case, are a bit different. And of course, I will share these results with the IOSC Association members, because yeah, it's a pity. They are investing a lot in the IOSC, but basically researchers do not know anything. Okay, so we reached the end of the presentation. Thank you for your feedback. So now I'm going back. I have to show you a video, but I don't know if it will be properly displayed. So let's check. Let's stop sharing. How can I stop share? Okay. So in the meantime, do you have any question on the previous? While I'm searching for the video, do you have any question on the previous lessons? So now I will start sharing a video on YouTube. I hope you will also hear the audio. If not, I will know the audio of the video. If not, I will try to put the subtitles because it's important for you to, to follow the story because it's very, it's precisely what we are going to see this morning. So let's see. Can you see the video? Can you see YouTube?
Yes, we can.
Yes.
And
Yes.
can you also hear?
No.
No
No, I
audio.
don't think so.
Yeah, so simple read the subtitle.
Yes, we can read them.
Okay. Even though you didn't have the okay. Even though you didn't have the audio, I think you could follow the story, okay? And I think you can relate. I think you can relate to this situation because it's quite similar to the one that we saw during the Mentimeter, okay? So let's go back to the slides and let's start the proper lesson. Here we go with the slides. Okay, so just a short recap for people not attending the first two meetings. We are here because in Europe, open science is becoming the new normal, okay? And we will discuss the European Open Science Cloud later today. And as you can see here, one of the objectives of the European Open Science Cloud, so the EOSC, is that open science practices and skills are rewarded and taught, becoming the new normal. So that's why we are here. And why do we need open science? Because as we saw last time, COVID-19 showed that only sharing data and results, science can progress, and only if you share them immediately, not after 12 or 18 or 24 months, okay? We gave some data about how much money we spend every year in order to give you access to the content via subscription to journal. So we are paying $10 billion every year for subscriptions, and actually we are paying $10 billion to lock the content for people not having subscription, but this content was produced by public money. So this is the very important message of the first module. Today, reading is not for free. When you read a paper, when you download a PDF, it's not because it's for free, it's because your library paid a huge amount of money. Actually, the University of Turin is paying every year 4.4 million euros in subscriptions, okay? So it has been calculated that every year we spend from $3,800 to $5,000 for each article in subscription, okay? We are not talking about paid open access. In subscription, but basically we are closing the content for anyone not having the subscription. We have 70% of studies not reproducible, and we have 43% of retractions for fraud. Which means data fabrication, data falsification, and so on, with a direct correlation between the number of retractions and the journal impact factor, meaning that the higest the journal impact factor, the highest the number of retractions. And that's because evaluation became an obsession and people game the system at every level. So if you are curious about these topics, please go and watch the recording of our first module. About evaluation, this is an important reminder because research assessment criteria are going to change. The European Commission launched this coalition for advancing research assessment back in 2022. More than 400 research performing institutions, including the University of Turin, has signed the coalition. They are reforming the criteria, okay? No longer using impact factor, no longer using journal rankings, rewarding you for your collaboration attitude and something like this. So really rescue is on its way. And they are doing it right now. So once you sign the coalition, you have 1 year to show your roadmap and 5 years to show the first results, so the first changes in research assessment. So it's happening now. Given this situation, we need more transparency for a sounder and more effective and inclusive scientific process. That's why we need open science. And by open science, we need this umbrella term, including open access to publication, open source software, open educational resources, open notebook, open innovation, citizen science, open evaluation. The concept here is to open every step of your research process as early and openly as possible, as we discussed last time. And another important message is that our focus is on the entire process, not only on the final output, which is the journal article. Today, we are going to deal with the fair open data, so with this component of open science. Last time we saw this open science rainbow by which you have one or more tools to open up every step of your research. So technically we are there. What is needed is the cultural shift, okay, the mindset shift. So everything should be open by default. You should keep closed only if you have valid reasons to keep your stuff closed. All the more so because in Horizon Europe, open science is mandatory. It's a methodology, so it has been included into the scientific excellence section of your proposal. That's the important point. As I was saying at the beginning, open science is part of the evaluation of your proposal. So in order to get funded, you need to show the Commission how you are going to adopt and adapt open science practices. Okay, and we are having an entire module on March 27 to see how open science needs to be addressed in Horizon Europe. Today, what we are going to see, why we should take care of our data, useful tools to properly manage the data, and the theory of FAIR principles, because next time we are going to see practical tools to make your data fair and how to draft a data management plan. During this module, you will see this label, DMP, Data Management Plan. So in this slide, we are talking about a tool that you might need in order to draft your DMP. Take-home messages.
Yeah. Oh.
Sorry, please, can you mute your mic? So we have 3 steps. First of all, you need to manage your data. You need to make them fair, and if possible, you need to open them. So I will come now and again on this concept because it's very important. And this is another really key message. Data management is in your own interest, okay? So properly managing your data is in your own interest as a researcher, as we saw during the Menti, as we saw in the video. If you do not store properly your data, if you do not document your data, if you do not give access to the software, if you forget to label your spreadsheet, it's a mess, okay? But it's a mess in the first place for yourself, okay? So open, close does not matter here. It's just good research at stake when we are talking about data management. I see you if we were in a physical room, because managing data is not an easy task. And unfortunately, there is no recipe, as data are unique. Okay, so basically, every data set is unique, every research is unique, so there is no one recipe. There are so many aspects to be taken into consideration, and we will see them. So many tools to get used to. Of course, I can only present as many tools I can, but then you have to go through them, you have to taste them, and to see if they are suitable or fitting for your research. In the first place, it could seem so time-consuming. But I can tell you that the benefits are really huge. And you can imagine Donald Trump here saying it's huge, okay, like he used to do. It is time consuming, but then you will spare a lot of time in the future. Why should we care about data? Here we are going to have some, to see some reasons why we should care about your data. First of all, because if your data are not reusable, it's just a selfie of your data, okay? That's me taking a selfie at the seaside. This is an important message coming from Dasapta Erwinirawan, a researcher from Indonesia. He was showing this map. This is a map of the last earthquake they had in Indonesia. So you see the points, okay, of the damages of the earthquake. But as you can read here, those data points are not really data points. They are just a selfie of data points because they are not reusable. And that's the same for your data, okay? If your data are not reusable, they are useless, okay? Really useless. They are just a selfie of data and nothing else. Why should you take care of your data? It's the video we just watched together. As you might have noticed, there is no backup, just one USB drive, no data legend, no software to accompany the data. But the first researcher is telling the author that his data were generated with public funds. They were published in Science, which requires your data to be available, and they might be useful for a different discipline, okay? At the beginning, she was saying, I'm an oncologist. And he said, I'm not an oncologist. And she said, but I think I can make use of your data. So that's another important point in the video we watched together. So why should we care about data? First reason, or better, reason zero. They are the foundation of responsible research. Last time we discussed responsible research. If you don't have good data, you can't do responsible research, okay? As you can see in the vision of the Harvard University team dealing with data, research data are an important asset to our university and our researchers. And as you can see, the motto of the Digital Curation Center, because good research needs good data. And that's it. Okay, thank you for your undivided attention. And that's it. No, again, I'm kidding. Why should you care about data? Because data are crucial to make open science the new normal. If you want to read the introduction of this Science Europe practical guide, you will find this message here. As we were discussing last time, in open science, every step should be transparent, but of course, the foundation of every step are data. Why should we care about data? Because we have to. We saw last time dealing with the European policies that we have the directive 1024 of 2019, the Public Sector Information Directive, now called the Open Data Directive. They included research data into public sector data. So research data resulting from public funding must be open, okay? Must be, okay? Non should. Must be according to the principle as open as possible, as close as necessary. And don't forget Horizon Europe. If you signed an agreement in Horizon Europe, the beneficiaries must manage the digital research data responsibly in line with the FAIR principles, okay? And again, according to the principle as open as possible, as close as necessary, as you can see here. Another reason why we should care about data is, again, because we have to. A growing number of journals and publishers ask for data to be published with the article, both for reproducibility reasons and for transparency purposes. We saw last time the increasing number of retractions because data are not available, data are fabricated, their data are falsified. So that's why, as you can see here, many publishers ask you to give access to your data. Another reason is in our own interest, because as we saw at the beginning last time with the lessons we learned during COVID, we need data, okay? The COVID made it clear. We need data, we need the virus sequence, we don't need the blah blah of the journal article, we need the actual data. As you can see, the Research Data Alliance recommendation during the COVID, okay? Again, everything should be as open as possible, as close as necessary, and timely, which means immediately, as early as possible, shared. Why should you care about data? Again, it's in our interest because data get lost, as we saw in the Menti, and as you can see in this example, a PhD student whose backpack was stolen, okay? Cash reward because the backpack contained a laptop with 5 years of PhD research, okay? But it's not just that your backpack can be stolen, and that's why I really appreciate your reply on multiple sites. You need to store on multiple sites because in 2021, a French cloud services got lost after a fire, okay? So it's as simple as that. Data get lost for any reason. So a definition of backup is something that you had to do before because you don't know when your laptop will crash, okay? Or when your backpack will be stolen. And why should we care about data? Because data are fragile. If you look at this graph, you will see that in 20 years, 80% of the data, let's say, underpinning published article will be lost, okay? And it's a waste of public money because you have to recreate this data. And that's why you need a data management plan. That's why you need to safely store your data. The data management plan is not the absent administrative burden. It's actually the way in which you are sure that your data will be safe because you are taking all the measures to properly manage your data. Again, why should we care about data? Because if the data underpinning publications are missing, at best, expensive research is of little or no value. At worst, we are putting into clinical use, for instance, results of invalid research if you are not able to give access to the data, okay? That's another important message by Katrin Wichtenbeard. Why should we care about data? To ensure integrity. So again, it's in your own interest as researchers, okay? Data can be manipulated. Look at these two photographs. This is Stalin, of course. You might have recognized him. In the original photograph, Yezhov was with him. Then Yezhov was killed because he became an enemy, and the photo was manipulated. Okay, so again, if you give access to your data and if you properly manage your data, you are sure about the integrity of your data. Some data, like the one that you see here, this is the midnight sun up in Norway, up to the northern, to the polar circle. So I saw it. It was one of the most beautiful experiences in my life, but it was once in my life, okay? Some data are unique and not reproducible. Think about weather events, think about earthquakes. They are not reproducible in a lab. Data can be reused. If you think about the Hubble telescope, they found a planet 10 years later than the Hubble experiment was over, simply because the data were there, the data were available for other researchers to use. So that's another important message. Data can be reused, can be valuable even after your experiment or your research is closed. And often they can see and they can be reused in unpredictable ways. Look at this sentence from Rufus Pollock. The coolest thing to do with your data will be thought by someone else. Again, data create value. So as you can see in the OECD report, access to data boosts innovation. Okay, this is another important message. And data creates bridges. We saw in the video, she was an oncologist and she was asking data to a researcher of another field because data creates bridges between traditional disciplines. And that's a very important, that's a crucial message. If you think about Horizon Europe, you know that one of the other novelties in Horizon Europe are the missions, okay? We have 5 missions, and missions by nature are interdisciplinary, okay? So you need data to be available for researchers in different disciplines if you want to address societal challenges like climate change or cleaning waters or even cancer, okay? You need interdisciplinarity. We should care about data to be reproducible, and we referred to the Turing Way handbook, and we need data for research integrity, and we referred to the European Code of Conduct for Research Integrity. We should care about data also to allow for validation and checks and to detect errors and fraud, like you see in this paper. This was a PhD student asking these two prominent economists, Reinhardt and Rogoff. The International Monetary Fund based its policy on the study of Reinhardt and Rogoff, okay? This PhD student asked Reinhardt and Rogoff for raw data of this study on which the International Monetary Fund bases its policy, and they found mistakes. Selective exclusion of data, unconventional schema of weighting data, and also a mistake in the spreadsheet. So if you give access to data, frauds and errors can be detected. And the same happened with the vaccines, because there was this scientist from the United States, Peter Doshi, asking Pfizer and Moderna to see the raw data, and he couldn't get the data in order to check the effectiveness of the vaccines. We should care about data for a sounder science, because if you think about it, if you just publish the final results of your data and you don't publish of your research, sorry, and you don't publish what's in between, so the entire process and the raw data, it's just advertising your research, but it's not research. It's not research in itself. If you have no data, it's just a matter of laziness, or are we shifting towards scientific misconduct? I'm of this opinion. So I think we are shifting toward scientific misconduct, again, fabrication, falsification, and plagiarism. To me, data are like footnotes. I might not always read them, but I get suspicious if they are not there. This is Alastair Dunning speaking at the TU Delft in the Netherlands. So dealing with data, everything you see in this slide are data. But if you think about your replies to the Menti, you said statistics, number, So our first thinking is about something like this, okay? Maybe a spreadsheet with some number. But actually, this is data for a meteorologist. This is data for a philologist, sorry, for an archaeologist, for again a meteorologist, or for someone studying the Middle Age, someone studying history of art, and as you can see here, everything you see here is data. Okay. We can talk about data diversity like we do with biodiversity. The definition of data I like more is the one that the ALEA people gave in this report. We are going to see it now and again during the presentation. We could define data as all materials and assets scholars collect, generate, and use during all stages of the research cycle. Okay, so if you think about all your research assets as research data that could be potentially reused by other scholars, that would be great. And consider how useful it would be for you and for your own work if others share their data. Think about at least once in your life when you were happy to discover that the data set was already there and you don't need to waste time and money to create the data. We are going to see now some data basics, and as you can see, this is relevant for DMP. 5 ways to think of your data. This is relevant for the initial section of your DMP when you have to describe your data set. The way data are collected. Are you collecting data in an experiment, in a simulation, in an observation? Are they simply reference data? The form, are they text, spreadsheet, videos, photos, audios, codebooks, transcripts, software? The format, so by format, I mean, are you dealing with doc, or are you dealing with PDF? Are you dealing with an Excel spreadsheet or CSV? This is relevant for long-term preservation and for accessibility, because not all researchers, for instance, use Microsoft Word. And the size is quite important, because when you need to store your data, some repositories like Zenodo, they are for free, but they are for free until 50 giga per record, okay? If your data are bigger in size than 50 giga, maybe you have to pay. If you are generating terabyte of data, you surely have to pay to store them, and maybe also to run the software you need to analyze them, okay? And then the workflow phase they are in. Are we talking about raw data? Are we talking about processed data? Because sometimes raw data are too heavy, too big in size to be preserved. So you need to appraise, okay, and decide what you are going to preserve or not, and for the reason, and the reason why you are preserving or not, okay? So this is really very relevant for a DMP. These are examples, okay? As I was saying at the beginning, there is no recipe. There is no recipe. So depending, and that's why in the Menti I was asking which field are you from? Because maybe for an archaeologist, that could be relevant one tool. For someone in the biomedical field, this is not relevant, okay? But again, that's why I'm showing you a lot of, examples, a lot of suggestions. They might fit, they might not fit, they might be suitable, they might not be suitable. It's up to you to go over them and to see if it's fitting or not. Here you have other examples of the kind of information that you should put in the first section of your DMP. Bearing in mind that data are not static, okay? There is a research data life cycle, as you can see in this figure, starting from planning and designing your research, so collecting or capturing data, analyze data, maybe collaborating with others, managing, storing, and preserving your data, sharing and publishing them, discover, reuse, and cite them, and maybe by discovering data, you get another, scientific question in your mind. So you start another hypothesis, you start planning again, and that's why this is a cycle. And as you can see in this figure coming from the MIT, from the University of Harvard, from the point of view of our universities, they should be able to provide services for every step of the research cycle. Okay, as you can see here at the University of Harvard, they are providing 14 services in the planning phase, 22 services in the active research phase, and 5 services for the dissemination and preservation phase. This is a good exercise for you if you want to think about some actions related to your own research in these steps, in creating data, in processing data, in analyzing data, and so on. That could be a good exercise before the next time, before we are going to address a data management plan. These are other examples coming from genetics, from chemistry, from archaeology, and as you can see, referring to the data life cycle, okay? So you have to be clear on what you are going to do when you are collecting, when you are processing, when you are analyzing, when you are publishing, and when you are curating your data, okay? This is very important for your DMP. And the last reason why we should care about data, and that's why I left it here because before the coffee break, it's because now we have the EOSC, okay? This is the library room in Vienna, in which the EOSC, the European Open Science Cloud, was launched back in 2018, so it was 5 years ago. EOSC is here to stay. Unfortunately, is not as known as it should be among researchers, because it's a seamless access to open by default FAIR data. Okay, so FAIR data are the building blocks of the EOSC. Huge investments from the European Commission, more than 4 billion euros. It's an ongoing process. We have the EOSC Association. I don't remember if I put the slide here, but anyway, we have the EOSC Association. The University of Turin is a member of the EOSC Association. You should consider to be a member too of the EOSC Association. What is EOSC? You don't have to think about cloud. Cloud is just an image. It's just a metaphor to convey a seamless environment, okay? It's not a cloud in a computer science meaning. Is not a repository. You don't upload anything into the EOSC. You simply make your data fair, findable, accessible, interoperable, reusable, so that EOSC services or algorithms can find them, and other researchers and other citizens or startups or innovators or even the industry can use them. Okay, so the EOSC is not a cloud for science; is a supporting environment for open science. So the focus is on open science, is not on cloud. And as you can see, one of the objectives, as we saw in the first slide, is that open science practices and skills are rewarded and taught, becoming the new normal. Okay, so that's basically the EOSC. And as you can see in this slide, unfortunately, I have no link because it was an internal meeting of the EOSC Association, and they didn't put the slide online, but anyway, you have the slide here. This is Michael Arendtov speaking, the head of the Open Science Unit at the European Commission. EOSC is a cross-cutting data space for research and innovation, because it can be useful also for industry, also for small and medium enterprises, and so on. Okay, so it's a basis for a science, research, and innovation data space. And how do you do it? By making your data fair. So EOSC is a web of fair data and related services for research, a place in which research data are easy to find, access, interoperate, and reuse. It's a trusted and sustainable research output environment in which these outputs are available within and across scientific disciplines. As we said, science nowadays is interdisciplinary and cross-disciplinary, okay? And why? Because we have to unlock the full potential of research data. Never forget that we are talking about research data created and generated by public money, okay? That's the point. It's public money. It's European money, so it's taxpayers' money to accelerate discoveries and innovation. And how is it done? Through access and interoperability of research data in a sustainable infrastructure, inspired by inspired people and with a robust governance. So that's how the EOSC is being built right now. And the important message, as we saw at the EOSC symposium in Prague back in November 2022, EOSC is here to stay, okay? Open science is increasingly becoming the normal at European, national, and institutional level. I would say, unfortunately, at least in Italy and at the University of Turin, it's not true, because our ministry is not involved at all in this process. And even at the University of Turin, we have this unit, we have a roadmap, but we are doing basically nothing, or I would say really a little to make open science the new normal. EOSC is enabling a web of fair data for science. And as you can see here, EOSC is here to stay. Okay, there is no turning back. So the sooner these open and fair practices will spread among researchers, the better for you. Because if you know some colleague from the northern countries, meaning the Netherlands, Norway, Sweden, Denmark, the UK, they are way beyond us in this process, okay? And as we saw last time, there is a risk of being a first mover, but there is a higher risk of being a follower, because the first mover will get also all the benefits of open and fair data. The strange thing is that if you look at the European Research Area Policy Agenda, the first action is precisely enable the open sharing of knowledge and the reuse of research outputs, including through the development of the EOSC. And as you can see here, basically all member states are supporting this action. But it seems that EOSC is not known among researchers, okay? That's really quite strange, but anyway. Another important message before the coffee break is that EOSC is based on data stewardship. Because as you might guess, as you might have guessed from the topic I've touched upon since now, until now, sorry, it's a complex matter. So we need data stewards in our institutions because it's complex. To manage data is complex, okay? So we need data stewards. It has been calculated that for the Open Science Cloud, we need, for the European Open Science Cloud, we need 500,000 data stewards, one every 20 researchers, okay? Because as we were saying, disciplines are different, data sets are different, research are different. And as you can see in the Strategic Research and Innovation Agenda of the European Open Science Cloud, establishing a data stewards network is one of the critical success factors of the EOSC. So that would be an important message for our institutions' governance. Who is the data steward? The data steward is a high-profile profession. Basically, I would say a PhD or more, because the data steward need data domain skills. As we were saying, data in archaeology are completely different from data in bioinformatics, for instance, or in medicine, okay? So the data stewards in archaeology should be an archaeologist, okay? At least a PhD, deeply knowing the data, the domain data. And then he or she acquires, let's say, transversal skills like IT skills, legal skills, community standard skills, and so on. But the core competencies should be on domain data. Sorry. Another interesting thing about data stewards, if I were younger, I really would become a data steward, because it's a fascinating profile in my opinion, because you are not a data engineer, you are not a data analyst, you are not a data scientist, you are not simply a data curator, you are a data steward. And as you can see here, you have a bit of all these competencies and skill, and you are steering them, okay? Because you are a steward. That's the interesting point in this new profession. And by the way, if you think about data stewards and the importance of data stewardship in this new data-intensive research, is also time to rethink the divide between academic and support staff. This is a great piece written by three amazing women, Marta Teperek, Maria Cruz, and Danny Kingsley. I'm so fortunate to, I can call them friends, and they are really amazing women, amazing open science champions. And they wrote this piece in Nature. We have seen how a diversity of roles and contribution drives progress and success in research and innovation. But still, the sharp distinction between academics and support staff is a barrier to effective research, because it discourages a culture of collaboration and appreciation, and I would add, rewarding of diversity of roles and contributions, okay? Because as support, I'm part of the support staff, and as you can see here, we are knowledge brokers, able to translate generic infrastructures, tools, and policies into practical solutions that make research more efficient. So it would be really time to rethink the divide between academic and support staff. And I would say this is another important message to our governance. What is data stewardship? Data stewardship is the responsible planning, and I would underline and stress planning, because as we are going to see next time on data management plan, it's a planning. You need to start on day 0 of your research, or better on day -1 of your research, to planning how you are going to manage your data. Anyway, data stewardship is the responsible planning and executing of all actions on digital data before, during, and after a research project, with the aim of optimizing the usability, reusability, and reproducibility of the resulting data. Another important topic here is that data steward has 8 competence areas: policy, compliance with funder policies, alignment with fair data principles, services, infrastructure, knowledge management, networking, and data archiving. Okay, and I would say that the key area is that the data steward is acting as a bridge among different professionals, like the data engineer, the data analyst, the legal advisor, and so on. Okay, so he can act. He or she can create synergies within our universities. These are the competence area, and as you can see in this report, they concern a lot of issues. That's why the sooner we put in place a network of data stewards in our universities, the better. As you can see here, FAIR principles are at the center, but the data stewards should act and should not act, I was wrong, should interact with policy people, with research people, and with infrastructure people. And his role is to define policy, to make researchers adopt the FAIR principles, and to facilitate the technical infrastructure to make fair and open a reality. Data stewards are, again, another definition dealing with curricula in our university. Data stewards is a data handling and management professional whose responsibilities include planning, again, implementing and managing data input, storage, search, and presentation. Data stewards create a data model. That's why they need to acquire also semantic web competencies and skills, okay? And they advise in each step of the research data cycle. That's really another important message. As you can see here, is the perfect profile is a PhD degree or equivalent experience. Is one data steward per faculty enough? Actually not, because in the same faculty, you might have different research group with completely different data. Think about our Department of Psychology. They have clinical psychologists and they have other psychologists. So the data they treat and they deal with are completely different. So here you have other, let's say, roles a data steward should play: analyze data management needs, provide advice and consultancy, liaise with key faculty stakeholders. This is crucial. Train and inspire, help comply with funders and journals policy, develop faculty research data policies, and prepare the faculty for the future. And you need skilled people. The University of Turin is a partner in this Horizon Europe project, I would say huge project, Skills for IOSC. We are also preparing curricula for data stewards and competence centers and the coordination of competence centers. So I would say this is the first break, because it's around 11 o'clock. So I'm stop sharing the slides. Is there any question in the chat? Yes, Claudio was saying, if you want, oh, sorry, I missed this one. Thank you, Claudio. For the next time, I will make use of this suggestion. Include computer sound. Thank you. Great. And then Eleonora is saying 4 billion spread across how many years? No, actually it's 4 so the total amount of money spent globally for subscriptions is 10 billions, okay? So worldwide in 2020, so 3 years ago, 2021, sorry. In 2021, so 2 years ago, we were spending globally 10 billions dollars, sorry. The University of Turin is spending 4.4 million euros per year, not across how many years. Your library system is spending every year 4.4 million in subscriptions. I hope this is clear. That's why when I go into department and I listen to researchers say, oh, but why should we pay in open access? Because today everything is for free. Today everything is not for free. You simply can read and can download the PDF because your library system at the University of Turin is spending every year 4.4 million euros. And that's it. Okay, so it's not spread among 10 years. Okay, it's every year. Okay, so thank you, Eleonora, for the clarification, because maybe I was not sorry for the voice, but as I told you yesterday, it was a wonderful sunny day, and I thought it was summer, so I went without, sleeveless and so on, and this is the result. This is the result today. So sorry for the voice. Maybe I said 4.44 billion, but it's not, it's million. But again, it's a huge amount of money. I can't even imagine how much money 4 million here is. Okay, and then again, Eleonora, yes, the RDM kit, we are seeing it in the second part of the morning. And Irene is saying, I'd like to have the recording of the first lecture. Yes, no, Claudio, I think we have to share we have to share the recording on the Zenodo website. So maybe if you can give me the link to the recording, we can put them on the Zenodo record, and then everyone can access it, because I think it's useful for anyone. Anyone was advised that the session would be recorded, so it is GDPR compliant, and there is no problem. So we can put all the recordings on the Zenodo record. Thank you. Yeah, sure. It's useful to access the recording. I think we also had useful interaction, but unfortunately today we are 35 people, but unfortunately during our first meeting we were only 14. The slides, as we were saying at the beginning, they are already available on Zenodo. Please, Gabriela, can you put again the link? Maybe Eleonora connected later. Can you put again the link into the chat? And yes, they are available. They are available and reusable because they have a Creative Commons license. So feel free to reuse them. They have a creative. Sorry, I joined later. Yeah, I see. Okay, no problem. That's the reason why we are recording the session, and that's the reason why the slides are available, because I know you are all busy. We are all busy. Okay. So any question on this introduction on data management? I think that you can relate with many things that we said during this first part. I leave you 1 minute if you want also to open your mic and to share your reflection. If not, we are going to have the coffee break, but 1 minute just if you want to say something or to write something. Andrea, I don't know if I'm pronouncing it correctly. In Italian is Andrea. Andrea is saying the information was useful. Thank you. I hope it is. Okay, if you don't have any, yes, I see one hand raised. Diego. I don't see any surname. Diego. Please go ahead. I think you can open your mic. Misclicked. Okay. Okay. So I would say see you at 11:15 and have a nice cup of coffee, because the second part will be more tougher. Can you say tougher? No, more tough. Anyway, you got the point. So see you at 11:15. Bye. During the break. If not, Eleonora, do you have any question?
Yes. Hi, Elena. Yes, I was thinking the following about what is going to happen thanks to the PNRR investments. I know that several consortiums of Institute of Research are going to build what we can define as a Italian open science cloud. Do you have any insights or opinions about this?
I think you are referring to the project carried out by the CNR, Operas, and Daria.
Yes, definitely. This is one of them. That I heard about another one more with a focus on social science, but I think the principle is the same. So creating
No, I think,
an Italian.
Yeah, I
Yes.
think it's the project that is called I for IOSC. And actually, somehow the University of Turin is part of it, because one of the partner of this project is Operas IT. And Operas is the research infrastructure in the humanities of social sciences the University of Turin is a member of. And actually, this afternoon at 14, 14, we have a meeting on that. So yes, the project is there. It will be a sort of, the part of the Italian European Open Science Cloud infrastructure for the social sciences and the humanities. The partners are DARIA, which is the European infrastructure for data and the humanities, Operas, Clarin, which is the part of linguistic, and ERIS, which is the part of the cultural heritage.
I put a link in the chat.
Yeah, but that's it. That's all we know for the time being. For the University of Turin, the coordinate, not the University of Turin, sorry, for Operas IT, the coordinator is Professor Enrico Pasini, and as I was saying, we are going to have a meeting this afternoon. So, but the project is still at the beginning. So, I think there will be. I know that will be a huge investment in building that, and maybe a lot of training, because in the humanities and in the social sciences, FAIR principles are not so commonly known. Or researchers are not aware. So I think that there will be a lot of awareness raising or training information and so on. But the project is still at the beginning. And as you know, let's say that the guidelines from the ministry are not so clear on how you can spend the money, how you can, what you can and you can't do, basically. But yeah, it's still at the beginning. The University of Turin is part of it via Operas IT, so if that was the question.
Thanks.
Maybe if you drop me an email later, we can discuss it after the course. Maybe you want to, maybe you want to be involved.
Thank you, Elena. Yeah, sure, I will do that. Also, I had the pleasure to meet you in Brussels a long time ago. Very long time ago. It was in the context of a conference, a closing conference of a project about open science. So I'm very happy to know that you're still working on this, and I knew your expertise is really invaluable.
Great. Yeah, so let's keep in touch.
Will do. Thanks.
Thank you. So I'm sharing again the slides. Okay. So to deal with data, we need to take a step behind. Like you see, this is the Oslo fjord. And if you go into data without this, let's say, preliminary step, everything will go wrong. So the first step in dealing with data, the foundation in dealing with data is that research data is not mine. Okay. As you can see in this tweet by Weiner Lusoli, Weiner used to work at the European Commission. Repeat with me, research data is not mine. I was paid to get it, I'll get a Nobel for it, but it's not mine. And why is it? Even though researchers, as you can see here, 73%, 74% of researchers believe they own the data they generated for their research. Actually, that's not the case from a legal point of view, because research data, or better, it's to the reverse. Copyright does not apply to research data, because data are like information, like mathematical formula. They lack this bit of creativity, which is when the copyright, or in Italian, the diritto d'autore, comes to the scene. Okay, data are not creative. raw data. I mean, okay, we are discussing dataset dealing with the R in FAIR next Monday. So here I'm dealing with data, not datasets, which are different. But data are not subjected to copyright because they are not creative. Okay, so data per se are not creative, so there is no copyright on data. If there were copyright on data, and now I'm saying today in Turin is partly cloudy and we have 15 degrees. Now everyone in the world, if they want to say that in Turin we have 15 degrees and partly cloudy sky, they should ask me and they should quote me. Okay, that's the reason why on simple information, data, and mathematical formula there is no copyright. Okay, I hope it's clear. I think everyone is familiar with Shakespeare's Romeo and Juliet. Okay, think about how many versions of Romeo and Juliet do we have? A tragedy, a ballet, some novels, music. Think everything about Romeo and Juliet. So what the copyright protects is the creative, the expression that Shakespeare or even the Dire Straits used to present the story of Romeo and Juliet. Is not the story of Romeo and Juliet covered by copyright in itself, okay? It's the expression, so the creativity that each author used to express or to present the idea of the two lovers and the two families, the two families who are enemies, okay? So that's why research data are not mine, because there is no copyright on data, because there is no creativity. I hope this is clear. If not, you can refer to this information guide created, among others, by Thomas Margoni, who is the expert, or you can refer to this open-air fact sheet, which is how do I know if my research data is protected? But as I was saying, we are going to have, I was saying tomorrow, but it's not tomorrow, it's on next Monday. We are going to have under the R part of FAIR, all the tools needed to go open in data and to go FAIR, based on the fact that there is no copyright on data, okay? There might be other legal protection, other legal agreements among the parts, mainly when you deal with data sets and not with data. And please notice that under the GDPR, if you deal with sensitive data, you always must state the legal ground of your research. And this is relevant also for your DMP, as you can see, you see the label. If you want to listen to this webinar held in 2020, or if you want to refer to this IOSC pillar legal compliance guideline for researchers, it's easy, it's clear, and they will explain why there is no copyright on data. Dealing with data, we have the 3 steps. I've already told you about the 3 steps in the take-home messages at the beginning. So hopefully all the data, all the research data should be open. The principle here is as open as possible. But if your data are not fair, findable, accessible, interoperable, reusable, it might be risky to put your data into the open, because they can be misused, they can be misinterpreted, they can be not interpret at all, as we saw in the Menti and as we saw in the video with the 2 beers. So if your data are not fair, it's risky. And that's why in the R part of fair, you need to provide all the documentation in order to make other researchers properly use and interpret and maybe reproduce your data and your experiment. But if your data are not properly managed from the beginning, it's almost impossible to make them fair, okay? You can read it also the other way around. So you need to manage your data, you need to make them fair, and if possible, whenever it's possible, you need to make them open, okay? Bearing in mind that today we are addressing only the first of this step, which is data management. Data management is, I would say, it's in your own interest, okay? You can keep your data closed, but you need to manage your data. I want it to be clear. It's not that you have to manage your data only if you are planning to open your data. You need to manage your data. And when I say manage your data, I'm thinking also about all of us dealing with files on our computer. They are data. So file naming, folder structure, versioning, and something like this. These are all part of data management, as we are going to see. This is the same concept. As you can see in this slide by Sarah Jones, who now is one of the director of the European, of the IOSC Association. Managing data is in your own self-interest. Making your data fair and open is for the community benefit. And as you can see on this axis, there is not, it's not binary, okay? It's not open, close, it's not fair or not fair, managed or not managed. It's a matter of a shade, okay? It's a gradient of fairness, of openness, and something like this. This is something we are going to see. Actually, if your data are not fair, in the R part, we are dealing also with licenses. So if your data are not fair, you can argue that they are not open because you can't use it if you don't have a license or if you don't have a proper documentation, okay? So open and not fair is not open, actually. So just to be clear, step 1, data must, and I would underline must, data must be managed during the entire life cycle, which we already saw. And by managing, I mean organization of your data, file naming, folder structures, versioning, and so on. Metadata, because your data should be properly described and should be discoverable for other researchers. Technique of backup and storage, as we saw during the Menti, this is one of the main problems because data get lost. Legal aspects and long-time preservation, which is crucial even, and all the more so in the digital age. So this is the first step. Data must be managed. And as I was saying, this is in your own interest, okay? Because your research workflow will be more streamlined. You will not waste time, again, in searching for a file on your own computer or in understanding which is the final version of the file that you may be sent for submission to a journal. Second step, data should be fair by design, because we are now in the era of the IOSC, of the European Open Science Cloud. So increasingly, data management and fair data management will coincide because of this concept of data that should be fair by design, meaning that you should create data that are already fair. So you need to put in place all the actions and you need to plan. And that's why you need a good data steward and a good data steward network in order to make your data fair by design. So second step, data should be fair by design. These are the FAIR principles. As you can see, they are very technical. If we have time, we are going to see the theory, so the principles today. And on next Monday, we are going to see the practical tools to make your data findable, accessible, interoperable, reusable. Something that I'm going to say now and again until you will get nauseated by me. Accessible does not mean open. Accessible does not mean open. The acronym is FAIR, Findable, Accessible. It's not FOIR, Findable, Open, okay? Accessible does not mean open because data can be closed if you need to keep them closed for a valid reason, provided that you, but not only you, because FAIR principles refers mostly to the machines. So even the machine needs to know where to find them and under what access conditions. Okay, that could be you have to sign a non-disclosure clause, maybe they are sensitive data, maybe there is privacy issues or something like this. Okay, so data can be perfectly fair but not open. We are going to discuss it later. Whenever possible, because as we said, the principle is as open as possible, as close as necessary, data should be open. And here on next Monday, we will have a section on open data. We will see again, these are the benefits of open data, better for research, better impact, better value. But the only reason is that open data save lives. And it was clear during the COVID pandemic, as we discussed during our first lesson back in February, okay? This was supposed to be the break, but we have already done it. So we can start seeing all the tools, okay? Beware, as you can see, these are, I think that the Portuguese colleagues will recognize them, pastéis de nata. They are one of the beauty of the humanities. So from now on, we'll see a lot of tools. You need to taste them. That's why the slides are available for you. You have to go over the slides again to see if the tools are suitable, if they are fitting to your kind of data, to your kind of research or not, and you need to practice. That's why I was saying it's impossible that our researchers learn how to do it and learn about every single tool, every single possibility. That's why we need a strong and motivated network of data stewards. If you want only the links that you find in the slides, you can refer to this Open Science in Practice project on Open Science Framework. We need to create a network. As I was saying, it's crucial. It's crucial because research data management is not easy. We need infrastructure. We need synergies between IT people, between the legal office, between metadata experts, which usually are in the libraries. So we need to create a network within our organizations, okay? And we need data stewards to be the leader of this network. This is again relevant for your DMP. You have 4 pillars in dealing with data management. One is the Digital Curation Center in the UK. The second one is the Australia Data Service. The third one is the Dutch Data Service. And the last one is a Dutch consortium of data stewards. These are really the pillars, because if you go through these websites, you will find training course, training material, practical advice, practical tools, theory, so explanation on what For instance, what persistent identifiers are, what you can do, and so on. So they are really useful if you want to go and to start your path towards data management. And there is a master working in Leiden, as you can see here, Leiden at Sunset, is Barend Mons, one, I would say, the expert with the capital E, sorry, in FAIR principles. He wrote some years ago this Data Stewardship for Open Science book, which apparently is not open, but as you can see, you can download the introduction. You can download the introduction, which is about 19 pages, 90 pages. And all the book chapters will open in the Data Stewardship Wizard, which is one of the tools we are going to see to draft your DMP. So it's open, of course, and the main point in Barend's approach is that at the moment, we have journal articles plus something. Often data are published like supplementary material, okay? So we have journal article plus something. We should go for the reverse. We should aim for the reverse. So having data at the center of scholarly communication plus some kind of documentation, explanation, metadata schema, whatever you want. But the center should be the data. If not, what we are going to do is like this. So we have to go for data mining. We have to go to mine data within horrible PDF in scientific literature, okay? So we are hiding the data, and then we have to go and mine to find the data, which is nonsense. We should have the data plus something, some explanation, documentation, and so on. Again, Barend writing a letter to Nature and pledging for funding organization to invest the 5% of research fund in ensuring that data are reusable. Taking care of data is ethical. Okay, that's why you should commit to use 5% of the research funds in data management, including hiring data stewards, because when you hire a data steward, it offers a huge returns on investment. Bearing in mind that FAIR also means fully artificial intelligence ready. Okay, there is a lot of blah blah about artificial intelligence, but if you don't give good data, artificial intelligence will fail. Okay. Of course, there are costs. There are costs in managing and in preserving data, of course, but let's reflect and let's think about how much would it cost not to manage and preserve data. If you lose data, then you have to spend again and to waste money, public money, never forget public money. You have to waste public money and time to create the data again. And think about your own experience. How much time do you spend in preparing the data? It has been calculated that you spend around 79% in preparing the data coming from different data sets or different sources. There is also this report, the cost of not having fair research data, which amounts to 10 billion with B, billion, 10 billion in direct costs and 16 billion in indirect costs for a total amount of 26 billion per year, which we are losing, okay, if we don't have fair data. If you have to estimate the costs, and again, this is one of the main point, I would say, in a data management plan, you can refer to this very simple fact sheet by OpenAir. It's just to estimate, okay? If you are producing data at 50 giga you can count around 100 euro. If your limit is 75 giga, around 350. If you have 200 giga, around 1,000. Okay. If you have more, the costs might be higher. So again, by OpenAir, this tool to identify and assess research data management costs, this is way more detailed. Okay. And this one is another data management costing tool. This one is the one I would recommend, the UK data service costing tool. It's a checklist of any aspects you need to be taken that need to take into account for data management costs. Okay, so this is very complete. You need to check, you need to estimate, you need to implement, and you need to plan how to cover these costs. There is also this storage cost evaluator at the Data Stewardship Wizard. It's no longer maintained as far as I know, but it can be useful just to give you an idea, okay? Just to estimate the amount of money you need. So let's dive into managing data. Why? And I would repeat it again and again. Good data management facilitates the reuse of data, which helps avoid duplication of efforts and mitigates against data loss. Okay? Bearing in mind, and we are going to see it in a while, that the first reusers of your data is you. Maybe in 2 years when you are going to write your dissertation or your journal article. Managing data might you might be desperate at the end of this lesson because no way, it's too time consuming, but it's useful because in the end, if you learn this technique, in the end, you will save time. Okay. As you can see, if you want to watch, this is a very short video, a few minutes from your fellow colleague from the University of London. Okay. You save time, you increase your efficiency, you preserve your data, you meet grant requirements, and you are sure about your research integrity because everything is transparent. You need to get it right from the beginning. She is Shalini Kurapati. She's an engineer. She used to work at the TU Delft, at the Technical University in Delft. Now she's working in Turin. Get it right from the beginning. I used to say from day 1, but now I'm saying from day 0, or better from day -1 of your research, okay? Start planning the same moment you have your research hypothesis, okay? How you are going to deal with your data. As the first reuser is your future self. Okay, so DMP is not a waste of time. Is important to make you yourself the first reuser of your data. Before boarding on data management, ask the right questions. Again, it's not a matter of learning by heart these questions, but go through them. Okay, at least for the first time, go through them. Start asking yourself, what should I do, for instance, at the moment of data collection? What should I do for a proper data storage or data backup? Okay, so these are a set of right questions. This is another set about planning, documenting, formatting, dealing with copyright issue, and so on. And this is a third one. Again, depending on your discipline field, you might find one or the other more useful or more fitting. These are tips and tricks on data collection, as you can see, coming from the European Commission. And remind, it's not a matter of open close at the end, but also it's a matter of security during the research. So this is why during the Menti, I asked you, where do you store your data? Because your data might be dangerous, okay? As you can see here at Harvard, they have this 5 tiers security chart, data that can be public, information, the disclosure of which would not cause material harm, but which the university has chosen to keep confidential, information that could cause risk of material harm if disclosed, information that would cause serious harm, and information that would cause severe harm to individual if disclosed. Okay, so it's not just a matter of not losing your data. It's not just a matter of opening or closing or being confidential and so on and so on. There might be security issue. And as I was saying at the beginning, if you are dealing with sensitive data, if you are dealing with GDPR data, if you are dealing with potentially harmful data, you need to store them not on the cloud, but on a secure server at your university. So you need to contact your IT people to ask for a secure part of a server and maybe also for secure ways of transferring. So maybe data encryption or something like this. You need to evaluate according to the level of riskiness. Can you say it in English? I don't know. Of your data, okay? Because it's also a matter of security. Okay, and if you want to refer to the original paper by Merce Crozas and others, you need to assess your data and you need to evaluate if your data can be public, controlled, public, accountable, more accountable, full accountable, or maximally restricted. Okay, so please go and have a check about the security of your data. And you need to prevent data breach, okay? So here you have some scenarios and some preventive measures provided by the UK Data Service. You also, from the perspective of the support staff or the governance, I would say an enlightened governance to engage researchers, okay? And again, Maria Cruz and Marta Teperek, Connie Clare and other colleagues, there is also Ellie Papadopoulou among the authors, these recipes to engage researchers with data management. But I think you can refer to them. You can also use this book as a sort of self-engagement, okay? Maybe if you go through one of the use cases, you can relate to them and you can start, being engaged and start to be active in data managing on your own data. If you need some training, and again, that could be useful for your DMP, I would recommend this data management expert guide provided by CESDA. CESDA is the European Infrastructure for Social Sciences, but the training is useful for anyone. What is particularly likable in this training is that at the end of this of each chapter, there is a section named Adapt Your DMP. Okay, so it's very practical. It's very helpful if you are drafting your first DMP to go through the expert guide and to the final section, Adapt Your DMP. This is the RDM kit that Eleonora was suggesting before, provided by Elixir. Elixir is the research infrastructure for biomedical, for life sciences. Again, you see this idea of the life cycle, and you see that for each step in the life cycle, you have the corresponding theory, you have tools, you have good practices to go for a good research data management. Another interesting training is the Essentials for Data Support. It's available for free online. Sorry, I forgot to mention also the CESDA Expert Guide, of course, is available for free. Again, you see different modules according to the different phase in which you are planning, research, harvesting, or sharing your data. This is useful also because you have a glossary, okay, about a data jargon, which might not be so familiar at the beginning. You need to go for reproducible science, and we saw last time that the best handbook is the Turing Way, with different modules, you know. This is the module about reproducible research, but as you can see, you are dealing with research data management, version control, licensing, so everything we are going to see. This is a MOOC, so an online, open course provided by the project EOS Synergy. It's about open science, but as you can see, you have a module on research data management. This is the specific module on data steward training. As you can see, plenty of material online, okay? This is more tailored again on social sciences because it's provided by the UK data service. This is a fast track. 3 videos, as you can see, very, I would say, it's quick, but it's just, you know, very basic. Just as a first approach, just to see what we are dealing with. It was created by Danish colleagues. 23 things. This is for data stewards, but it exists also for researchers, also for librarians. So it's, again, very quick, very practical, as well as this one. This is just a chart, as you can see, provided by Rio, which is a research ideas and outcomes. It's a great journal, a great open access journal. For the humanities as well, you have this Parthenos project about managing data in the humanities, because humanities tend to be different. Daria, Pathfinder to data management in the humanities, digital technology and practices of the humanities research, edited by Jennifer Edmond, but there is also contribution by Elspeth. Todd Cifra, who is the expert for the data management in the humanities. The Alan Turing Institute, Humanities and Data Science Special Interest Group, published this white paper, which is actually a sort of handbook to deal with data in the humanities, the Daria Gateway, the Open Methods, and the Ariadne Plus project for the archaeological community. So as you can see, plenty of material if you want to go for a proper training on this. Coming to the practicalities, to the technicalities, okay? So the data management ABC. First, this is important message. It does not matter if in the end your data are closed or open. I hope it's clear by now. It's important for you, okay? It's important for you to have your research streamlined, not to waste time to find the final version, to find the right version, to find what's in a column because you forgot to label the column or something like this, okay? And it's also a way to be accountable, okay? To be accountable if you are planning, if you properly manage your data, you are accountable with your community, with your peers, okay? That's the way I did the thing. Everything is transparent. Everything is declared into the data management plan. Why? Again, why it's important? As we were saying, first step is to properly manage your data, okay? Then you can make them fair by design, and open. If you don't manage your data, as you can see here, is a prerequisite, okay, for open science and simply for a good science, I would say. And these are the first step you have to take to make your data fair by design. We are going to have an entire module on fair. I think we can start today. Yes, we will manage to start today, and we will have an entire module on next Monday. Okay, but these are the questions you need to go through if you want your data to be properly managed and fair by design. This is quite the same, just for a good data management. It was created by the network of data stewards at the University of Bologna, because the University of Bologna already has a network of data stewards. They are Giulia Caldoni, Bianca Gualandi, and Mario Marino, one for each disciplinary area. They created this decision tree for data management, as you can see here. Are you generating new data, or are you reusing existing data, with the relevant questions? Okay. It's very, I would say, it's quick because it's all here. It's one page. I had to cut it because it couldn't fit in one slide, but it's really valuable and useful for you. Okay, if you want to approach this data management. First action: file naming. Are you sure that in 1 year you are going to know what's in the file named My Study? Or if the thesis version 12 is the final one? Once, when I was collaborating with the Italian ministry for drafting the National Plan for Open Science, I received a file whose name was Piano Nazionale Definitivissimo Finalissimo. I don't know if you know Italian, but anyway, it meant national plan, very final, very definitive version, okay? Which is really nonsense. So you have techniques, you have file naming conventions, and all the more so it's important if you are in a collaborative project. So if you have different partners dealing with different work packages, for instance, you need to agree at the beginning. Never forget this message. Get it right from the beginning. So you need to agree at the beginning of your project on the same file naming, which should be, of course, meaningful, okay? And not like very final, very definitive, final file, okay? This is true for researchers. This is true for any of us dealing with file on our computer, okay? But all the more is true if you have partners. Here you have some file naming conventions. It's also important for the folder structure. Here you have two examples. One, you can go for data, documentation, questionnaire, and then subfolders. Here you have another example going for data, then split into database, images, sound, text, and then another level, documentation, consent form, information sheet, methodology, and so on. So you need to provide a good folder structure, and of course you need to declare it in your DMP. So everything should be clear, because the DMP is both a declaration towards others, researchers, or to the funder, but it's also, and it's mainly, a working tool internally for the consortium, because you have to agree on the file naming, you have to agree on the versioning, you have to agree on the folder structure, and so on, from day 1 or day 0 or day -1, okay? Because it's difficult to recreate a folder structure at the end of the project, and basically it's pointless. The first section of a good DMP, and what we are talking about, is basically a README file. And a README file, I don't know if you are familiar or if you have ever drafted a README file, which can be the first part, okay, of your DMP. A README file is like putting yourself in someone else's shoes, okay? This comes from the Open Life Sciences course, which we see now and again. Here you have examples. This is coming from the Cornell University, a guide to write a README file, a template, as you can see here. Here you have the template at the MIT in Boston. These are all suggestions, okay? This is the TU Delft template. These are examples of what you have to document, both in the README file and in the entire DMP. So these are, for instance, example of what you have to document. Okay. For instance, the list of variables, the list of labels, the source of data, the dataset version, and so on. Speaking about versioning, again, you have some techniques, as you can see here. It's important to keep track of versioning, maybe creating a chart, okay? Documenting the differences between version 0.2 with respect to version 0.1, for instance, okay? So this could be, again, it seems time consuming. I can tell you it's useful and it's actually time saving in the end, okay? Because then you have everything documented, okay? And you don't need to waste time to go through it again. For versioning, you also have relevant information in the CESDA training guide. They suggested Subversion as a tool, as a software to help you. But some researchers told me that they use Git, for instance, which is a version control system more efficient than Subversion. Another easy recipe, as we saw last time, is to use GitHub. Okay, GitHub is perfect because it has a version tracking. It's also a great tool for collaboration, just for your entire project. It's also a great tool, and I could never have imagined it for project management, because you have a checklist for tasks, who is doing what, and so on. So it's really a great tool, not only as a repository for software as I used to know it. Another tool that you could try, again, you have to taste it. I don't know if it's suitable or fitting for your research. OpenRefine, which seems to be a powerful open source tool for working with messy data, cleaning it, transforming it from one format to the other, extending it with web services and external data. I don't know if it's important for you. You have to try. Suggestions for data entry. As you can see, for instance, conduct data entry twice, minimize the number of steps. Again, these are tips and tricks, okay? Suggestions to have a better data management. Good tables is an automatic check to validate tabular file. You can try, maybe it's not useful for you, but it's here to be tried. And also this QM my data, it's a validation. So you put into the system the check value, and then the system checks if there is nothing wrong in your spreadsheet. Okay. Talking about storage, and that's why I ask you, where do you store your data? Because in this report published at the end of December 2022, European Research Data Landscape, it seems that around 60% of researchers still store their data on personal physical storage devices. Okay, which, as we said, is not a good recipe, or better, it's a recipe for disaster. Okay, it's a recipe of disaster because you don't know when your laptop will crash. Okay, basically, or will be stolen. And again, this is a cartoon about how scientists save important data. Look at the red part of the pie in their own memories just before the computer crashes, losing everything, or in weird files with strange acronyms, or in writing it down. Okay, so this is not the right way to store your data. You actually have to ask yourself, it's short term, so it's during the research, or is long term? So this is the basic question. And as you can see here, you have different storage solutions suitable for short term or long term, with advantages or disadvantages. Always store data in an open format, unattached to a specific software supplier. If you need a specific software to read your data, bear in mind the example of the video we watched together. If you need a specific software, you need to provide access and to store the precise and the exact version of the software you use to process your data. Use a data storage strategy in which at least, I would say, at least 2 different types of storage media are used. Copy or migrate data to new storage media every 2 to 5 years. I'm old. My PhD thesis was on floppy disk. Maybe some of you don't even know what a floppy disk here is, okay? Because you were born with USB keys. So if I hadn't migrated my PhD thesis on a USB drive and on the cloud, nowadays I couldn't read a floppy because there is no physical device anymore in the current computers and laptops. Okay. Never write an old backup with a new one. It's better to make an entirely new backup of changed file. And regularly check the data integrity, for instance, with a checksum checker. If you deposit your file in Zenodo, like where you will find the slide of the course, Zenodo uses a checksum checker. Organize and document research data. It's about the FAIR principles, so we are dealing with it during the next module. You have different solutions according to the type of your data, bearing in mind, as you can see here, that there might be disadvantages or risks to put personal data, sensitive data, GDPR data on the cloud, okay? Because there can be a data breach, okay? So please contact your IT people. In order to make a decision, to make up your mind on what you have to preserve, you need to go for appraisal. Okay, it's a specific technique which is called appraisal. You might, because as we said, preserving data in the long term has costs. Okay, you might not have costs. In Italy, a lot of projects in library, projects about digitization of old books, they failed because they didn't foresee the costs for future storage of terabyte of data generated by digitizing old books, okay, or manuscripts. So in order to decide what to keep in the long term, you need to see if the material is relevant to the mission of your research performing organization. If the data are unique, if they are not replicable, even go for the cost-benefit ratio, okay? Some data might be less costly if redone or if recreated in 10 years, then to keep them for 10 years. Like, for instance, the genome sequence. It's easier to be redone in 10 years than to be preserved for 10 years, okay? If you want to know more about learning how to manage your data, please refer to these modules about the Foster training course. If you want to learn how to protect your data, there is a specific module on data protection and ethics, because if you are dealing with personal data, you need to be more accurate, okay, in managing your data. You have legal requirements coming from the GDPR, the General Data Protection Regulation. In the GDPR, you always need a valid legal basis to process your personal data. This is the so-called research exemption of Article 89 of the GDPR. Please refer to the CESDA guide if you want to know more. If you are dealing with personal data, you need to process lawfully, fair and transparent to keep to the original purpose. This is very important. If you got the consent for a specific purpose, then you can't use the data for a different one, okay? You have to minimize the data size, you have to uphold accuracy, remove data which are not used, and to ensure data integrity and confidentiality. Why I was saying you need to, and a good data steward should create synergies within the institution, because here you see all the applicable laws to data. That's why you need to create synergies with your legal unit, okay? And within the legal unit, there must be an expert on the legal aspects of data. If you're dealing with GDPR data, you can refer to this very complete guide on GDPR in research. You should have a look at this map, which might look like a London Metro map, but actually it's behind this map you have all these questions. You should answer to if you are dealing with personal or GDPR data, because if you got to this station, you have to stop research, okay? If you have no legal ground for processing data, you need to stop research. That's why you need to start from the beginning. You can't get to this station after 1 year of your research project going on. For the consent, you have this wizard provided by Daria. It creates a specific consent form according to your needs. So you reply to the questions, and the consent will create according to your needs. If you need to anonymize your data, first of all, we need to be on the same page on what anonymizing means. You have direct identifiers, you have indirect identifiers. So here you have this, I would say, guide provided by UK Data Service. And you could try Amnesia, which is a software provided by OpenAir to anonymize your data. Data needs to be cited, of course, in a different way. So you have a template to cite your data and to get cited, okay? There are studies, I forgot to put in the slides, showing that if you share your data set, you got even more citation to the eventual paper linked to the data set, okay? So again, it's a way of getting and becoming more visible, more citable, more, I would say, recognized as the expert in your field among your community. And of course, data have to be measured. Again, I remember Barenmons some years ago saying you can't keep evaluating researchers with the same tools as we used before. Okay, so you need, as we are sharing more and more data, you should need different metrics, different indicators, okay? And that there is this project which is called Make Data Count. They are looking for new indicators for data. That was the sentence by Barent. We can't measure a new science with old indicators. In the end, love your data and help others love it too. This is the final message of the data management first step, bearing in mind that this is just the first step. Then we have to make our data fair, and then we have to make our data open, okay? So I'm stop sharing for a few moments just to see if we have other questions in the chat. No? Okay. Do you have any question on what we have saying in this module about data management? Okay, if not, I would go for a very short break just to, just to have a quick cup of coffee or just to have a fresh air. So please be back at 12:25 because we have to start with the session on FAIR principles. So the theory about fair, findable, accessible, interoperable, reusable. See you in 5 minutes. Bye. Okay, welcome back. I hope you are here. I can't see you, but anyway. And I hope that Claudio can start the recording again. Anyway, I'm sharing the slides again. Okay, it's difficult to know if you are there or not, but anyway, let's go with the second, the third part, I would say, in this morning session. So the first step, as we saw, is data management, which is not relevant if data are closed, open, or whatever. It's relevant for a good research, okay? Because good research needs good data. That's the point. Then you need to make your data fair by design. As we saw during the first part of the module, we are in the era of the EOSC, the European Open Science Cloud. So your data needs to be fair by design, because fair data are the EOSC building blocks. So that's why if your data are not fair, basically you become invisible, okay? Not visible by anyone, and your data will be useless. That's the term. Remind that in Horizon Europe, responsibly managing your data according to the FAIR principles is one of the mandatory practices, okay? And you need to give an overview of your data management plan, one page, in the excellence section of the proposal. We are going to have an entire module on open science in Horizon Europe on March 27. So stay with us to know more about how open science is dealt with in Horizon Europe. In this module on fair by design, we will learn what is fair by design in the daily practice and in Horizon Europe. And the key message is fair is the future, or should I say, is the present, okay? As I was telling you during the first part of the module, in the northern countries of Europe and in the States, they are way beyond us in managing their data in a fair way, okay? So there will be more visible, their data will be more reusable, there will be more linked to the society or to the industry, depending on your field, okay? And actually, it's easier than it looks like. We will see that a good repository is taking care of a lot of the FAIR requirements, okay? So for instance, a good repository like Zenodo is taking care of a lot of FAIR requirements. This might be your reaction when you hear about FAIR. Don't be afraid, because you are not alone. As you can see in this report, the State of Open Data 2020, at least 60% of researchers in 2018 said they have never heard of the FAIR principle before now. It seems that in 2020 it was reduced to 40%. We can compare the results of the Menti of this morning. I would say that it's time to dance with FAIR, like this window I saw in Amsterdam last week, because it seems that still 38% of researchers have never heard about the FAIR principles before, okay? But anyway, at least 62, 57, 64, 70% of them recognize that they are important to connect their data to your data, to reuse your data, to access your research data, and to find your research data, okay? So at least it seems to be important in this report called the European Research Data Landscape. If you want to know how FAIR principles can benefit you, please refer to this video. It's again 3 minutes video, but we have no time to watch it now together, created by GoFair, which is this initiative, a Dutch initiative or international initiative for fair data. The image is that of a train, okay? A train calling at some stations. The station are your data set. They call just at the station they can recognize, okay? And that's the same for the machines. If your data set is correctly described via metadata, the train stops and the train calls at your station. If not, they simply will ignore you and will ignore your data. So that's why that's the importance of FAIR principles. The original paper was published in 2016, the FAIR Guiding Principles for Scientific Data Management and Stewardship. As you can see, Barend was one of the authors. To be findable, you need identifiers and metadata. And on next Monday, we are going to see practical tools to make your data findable, accessible, interoperable, and reusable. To be accessible, and again, the acronym is FAIR and is not FOIR. So accessible does not mean open. It only means that you and machines need to know where to find the data and under what access condition. And you need open formats, your open protocols to be harvested, and so on. To be interoperable, you need standards and ontologies, and to be reusable, you need licenses and documentation, as we were already discussing during this module. All the above should be not only for human eyes, but should be machine readable, and all the more so machine actionable, okay? If you want to know more and not to make mistakes about the FAIR principles, you can refer also to this paper, which was published in 2020 about implementation and interpretation and consideration. The idea of FAIR principles is to be kissed by the machine. As you can see, this was one of the slides presented by Barend at the first International Conference on Fair Digital Object back in October 2022. So if your data are not fair, the risk is to be missed by the machine instead of being kissed by the machine, okay? Bearing in mind that FAIR means findable, accessible, interoperable, reusable, but could also mean fully AI ready, so fully artificial intelligence ready. If not, you will be missed by the machine. And speaking about data and intelligence and artificial intelligence, if data are not good, artificial intelligence does not work, okay? And if you want to know more, and if you want to know how artificial intelligence can harness about open data and about fair data, this is the startup created by Shalini Kurapati, the engineer we already mentioned. Okay, she's working in Turin now. This scenario would be for research data to be used also beyond academia, outside academia, okay? And one of the first beneficiary would be industry. Because as you can read here, this was an entire issue of data intelligence dedicated to fair data. there is this article about the need of industry to go fair, okay? Because, as you can see here, research data is one of the most valuable resources we have in the world, as it's the key ingredient to innovation, ultimately leading to societal benefits. Every element of data could potentially contain a clue that can lead to an important discovery. However, in industry, much like in academia, research data is rarely leveraged beyond its original intended purpose, not only based on deliberate data protection, but also on a lack of findability. Okay, that's why it's important for your data to be findable, accessible, interoperable, and reusable. The focus is on the R, on the reuse, and again, never forget that we are talking about data created by public money, 85% of which is never reused, okay? This is not sustainable. This is Ursula von der Leyen speaking at Davos in 2020, okay? It's public money. Data created with public money should be reusable for anyone, included industry. And our target should be to have data fair by design. These are the FAIR principles. As you can see, it's another table, okay? It's a sort of, translation of the FAIR principles, as you can see here, and the compliance to the FAIR principles, bearing in mind, again, that accessible does not mean open. Data can be closed, provided that you and the machine know where to find them and under what access condition. Also for the humanities, don't think that the humanities are not included. You have an entire report from Alea, sustainable and fair data sharing in the humanities. So if you are from the humanities, please refer to this valuable book. There are also FAIR principles for research software. They were finalized at the end of 2022. As you can see, some are the same as the general principles, but some were adapted to software, which is quite different from data, okay? And of course, you need software management plans in order to be fair for your software. Here you have all the references. Even in citizen science, you need to be fair. So here you have the standards for citizen science. Something about the difference between fair and open. Hopefully, there will be an increasing degree of overlapping between fair data and open data, okay? But there will always be perfectly fair closed data. And I can give you two examples. One is very clear, coming from a researcher here at the University of Turin. She was in the social sciences. She was dealing with political refugees in Latin America. So when she had to draft the DMP for her project, she said, okay, I'm funded in Horizon 2020, but I need to keep my data closed, no problem. Because of course, if you make, she ran some surveys, okay? Surveys and questionnaires and interviews with political refugees in Latin America. If you anonymize the data too much, they will be useless. If you put this kind of data in the open, the life of the political refugees will be at stake, okay? So you can't make this kind of data open, but they must be fair. And I say must and not can. They must be fair, because if I am a researcher interested in political refugees in Latin America, why should I ask for more money and waste money, public money and time to recreate and to run again the surveys, to run again the interviews, if they are already existing, okay? I should know where to find them. I should contact the original author. I should ask permission to have access to the interviews, to the surveys, and so on. And I could, if the case, I should sign a non-disclosure agreement, okay, committing not to share the data myself. That's a clear example of fair data that can't be open. The second one, I learned giving a lesson to biologists. We were discussing citizen science. We were discussing citizen recording on their cell phones birds migrating, okay? And they immediately said, okay, and this kind of data must be kept closed. And I said, okay, come on, why? Because you don't have privacy issues or security issues with birds. And they start laughing and they ask me, and what about the hunters? So this is another example of a data set on migrating birds, which must be fair and must be closed. If not, you put the lives of the birds at risk. Okay, so your data must be fair, because if I am a researcher interested in bird migration, I should know that the data set is there, not wasting public money in recreating them and not wasting my time in recreating them, but it must be kept closed, okay? So closed data can be fair, and I would say must be fair. Open data can be not fair, but if your data are not documented and unscrapable in a repository which is closed, right, like ResearchGate or academia.edu, it's risky, okay? It's risky or useless that you put your data, not fair data, in the open. We have already discussed it. So fair refers to a set of principles. It's not a standard, it's a set of principles. So you can have, not can, I used the wrong verb, the right verb, you should, and you have to implement in a different way according to your discipline. It's not a standard. It's not equal to RDF or linked data or the semantic web. It's not just about humans, as we were saying, is for machines, and is not equal to open, okay? This is really important. If you want to know about FAIR in a nutshell, you can refer to this infographic, which actually is not just an infographic, because if you click on every icon, you will find the corresponding training material, tools, suggestions, tips and tricks. This one, for instance, is about persistent identifiers. There are some myths about FAIR. I cannot share my data because they are personal or confidential. Again, accessible does not mean open. Fair data, my data is too unique to fit one standard. Again, fair is not a standard, it's a set of principles. You can implement the principle according to your data. Fair data, why should I care about that? All that matters are citation and impact factor. And actually, we saw that things are changing in Europe because the European Commission launched this coalition to reform assessment criteria. And as you can see here, if you share your data, you will get all the credit you deserve. And hopefully in the near future, because it's happening now, you will be rewarded if you share your data. The day the EOSC was launched in Vienna, it was also published this report, Turning FAIR into Reality. As you can see here, you have recommended practices and you have supporting recommendation. Look at the first one, define FAIR for implementation in your own community. Implement a model for FAIR digital object. And actually, the digital object of the future should be this one. So at the core, you have your data code, anything that can be a digital object, a layer of identifier, a persistent and unique identifier, a layer of standards and code, and the most external layer of metadata, which is contextual documentation. We will see that metadata are crucial for for findability of your data. This is what we were saying in the take-home messages. If you look at the red lines, this is a slide courtesy Erik Schultes, who is, again, one of the main experts in Europe about fair data. If you look at the red lines, sorry, they are technical. So a good repository is taking care of assigning a globally unique and persistent identifier. A good repository is taking care of the fact that metadata clearly include identifier of the data they describe, that use formal language for knowledge representation, and so on. The blue part is up to you as researchers. It's because it's domain specific, okay? You have to use the metadata relevant for your community. You have to adapt the standards that your community is using. You have to describe your data in a rich way. So again, it's up to you. But as you can see from the figure, that the image that Erik choose, they are strictly interlinked. So they can't live one without the other. This is again a translation of the FAIR principles for dummies, as we all are coming through to FAIR. And as you can see here, you have the translation of the technical FAIR principle. Here you have what's up to you, so what's the researcher's responsibility, and what a good repository takes care of, okay? This is another important project because it's created bottom-up, communities sharing their tools. It's called Fair Data Collective. For instance, here you have a project for psychology, okay? This is the results of some workshop that Erik Schultes and Barbara Magagna, as you can see, they are the first two authors. They are running these metadata for machine workshops for single disciplines. If you are interested, we can contact them. In order to advance this convergence of communities, of disciplinary communities towards standards, it's important to start creating fair implementation profiles, meaning that a community, a disciplinary community gathers, they have a sort of focus group, they share their choices. So what globally unique persistent identifier are you using? Okay, so they draft their fair implementation profile, they share their fair implementation profile. The more fair implementation profile we have, the more communities will converge, okay, within the community in using the same standards, the same ontology, the same metadata schema, so that you get the widest possible interoperability. Here you have a paper on fair implementation profile, and here you have the fair implementation profile wizard helping you in creating your fair implementation profile. Again, I guess that while I'm speaking, you think in your mind, okay, we definitely need a data steward, because a good data steward takes care of a fair implementation profile, can guide you in this focus group, in asking you the right questions to create your implementation profile. So it's really crucial, and I would say urgent, that our institution get a data steward network, a strong data stewards network. If you want to know about FAIR at work, so the potentiality of FAIR data, it was presented at the OAI conference in Geneva back in 2021. It was an example coming from Africa during the COVID-19. They created FAIR data points. So the original data are not traveling. They stay within the hospital. So again, it's GDPR compliant. They stay within the hospital, but the train, okay, so the algorithms call at this station through metadata, okay? So the data stay there, it's the algorithm going like a train. Some practical tools, some, I would say, generic practical tools, because we are dealing with specific tools for FAIR, not tomorrow, but the next time. This is what verifying your data means. This image was created by the daughter of a researcher working at Sardinia Research Institute in Cagliari. So her name is Noah, and Anna, Lilian, and Charlotte were her friends. And she created these images. This image, I think it perfectly summarizes what verifying your data means, okay? From this messy data to a great research cycle, more streamlined, more effective, no waste of time, everything is transparent, everything is reusable, so it's great. I think it's worth it, okay? To verify your data, you need to start early, again, start from the beginning. And here you have an example of a verification process in an experiment dealing with sequencing. This is a practical guide coming from ZonMW, which is the funder for biomedical research in the Netherlands. It's very quick, as you can see. This is the chapter. I exploded this one. That's it. Okay, so it's quick, it's practical, and it explains what verifying your data means. You have the FAIR cookbook, which really is an excellent project run by Susanna Sansone at the University of Oxford and her team. You have recipes to make your data fair, dealing with findability, accessibility, interoperability, reusability, but also with the infrastructure, the assessment, the applied example, and the maturity model. You have recipes, and as you can see, you have the reading time, the difficulty, if it contains executable code. We will see next time in dealing with the specific tools to verify your data. The FAIR cookbook is popping up now and again. The FAIR toolkit, again, another support toolkit. You can choose the one that you like more or the one that is more suitable for your kind of research. This was created by the Pistoia Alliance, which is a project which gathers researchers and industry, pharmaceutical industry mostly. They decided to go FAIR because they saw how much more effective their research and development became after adopting the FAIR principles. This is, again, another interesting tool for you if you want to move your first step toward verification, created by Danish colleagues. But as you can see, is quick. 12 minutes read, 7 minutes read, 5 minutes read. So it's, again, a good guide if you want to be to start your path in verifying your data. Bearing in mind that verification is an iteration, okay? So you identify an objective, something to verify, you analyze data, you create data model, and so on and so forth. Then you assess the fairness, and then you start with another objective again, because FAIR is a process. We said as open as possible, as close as necessary, but we should say also as fair as possible, okay? It's a process. It's not binary. It's not either fair or not fair, okay? It's a process, okay? And to check if your data are fair, you have several tools. The Fair Sharing project, we are going to see several times, created this fairassist.org. You will find several tools to assess your fairness. I highlighted some. The first one is the Fair Evaluator or Fair Enough. These are the two I recommend. You put the DOI, so the digital object identifier of your dataset, and the system automatically check if the FAIR principles are met or not. Fair Aware, we are going to see it right now, it's manual. This is the first tool I suggest for you to check how fair you are. Simple questions. Does the dataset have any identifier assigned? It's good as a first approach, okay? It's good as a first approach just to ask you the right questions, but it's subjective. It's not for machine. But if you remember, we said that the FAIR principles are mostly for machines. So, okay, if you answer yes, they have a persistent identifier, but if the machine can't find the identifier, that's it. Your answer is useless. Fair Aware, which was listed in the tool we saw before. Again, it's important for you as a first approach. Are you aware that a dataset should be assigned a globally unique, persistent, and resolvable identifier? If you answer no, or if you click to the I icon, this is what will pop up, okay? A very quick explanation of what does it mean, why is this important, and how to do this, okay? So again, it's manual, but it's important to ask you the right questions. Fuji is automated, so you put the DOI, the fair maturity evaluator, put the DOI, and the machine checks, and fair enough is what I like more. You put the DOI of your dataset, and this is what you get, okay? So you get a green check, the fair principles were met. For institutions, and it would be a nice exercise to run this questionnaire within UNITA, within the UNITA consortium, because it's a self-assessment for institution if we want to be fair enabling institutions. This is the questionnaire. I would guess that we are mostly at the beginner step. I would recommend to take this questionnaire for our IT people or for the Open Science Commission if you have one, okay? And again, for institution, we have this recent tool, which is assessing capability, maturity, and engagement with fair enabling practice. Because the point here is that our institution should become, and I would say must become, fair enabling institutions, as fair data are the building block of the European Open Science Cloud. The European Open Science Cloud is here to stay, and open science is becoming the new normal. In many countries in Europe is already the case. If we are missing it, I think we are missing a great opportunity. So that's the final message. We have 1 minute left for the question. I hope there will be question in the chat. Okay, if not, is always scaring, because either everything was clear or nothing was clear at all. So it's a bit scaring as a trainer not to have questions. But anyway, It's 1 o'clock. I give you a few minutes if you want to, maybe just to share your reflections or I know it's a lot of material, as I was saying at the beginning. You need to go over it again. You go through again. It was dense, I know. We have only 3 hours. Usually this course on data lasts 9 hours for PhDs. But if we propose 9 hours course to researchers, they say we are busy, we can't do it. So there is a lot of topics to be, and a lot of tools to learn, and no time. I know it was dense. I'm sorry for that, but the slides are available. The recording will be available on Zenodo. You need to go over it. The important message is it's time consuming, but it's worthing. It's worthing. Okay? So please go again through the slides, the recording. I see Dan said quite dense, so it was clear. However, I was familiar with most of the content. Great, great. So maybe Dan, next time you can share your experience. Next time we will have more time to discuss because it will be the last module of the Open Science entire course. So we will discuss the entire course. So maybe Dan, if you next time, if you can share with us maybe your experience, maybe the tool, what worked, what didn't work, whatever. It would be highly appreciated. Gabriela says thanks. Oh, thanks, Gabriela, because you always put this link, so you are supporting me. Gael is saying, okay, I will try to have a few words ready. Great, Dan, thank you. It will be at the end, so you will have plenty of time even next Monday. Okay, so next Monday we are also using Mentimeter again. So thank you and see you next time.